Okay, we have a morphing triangle here. They say a triangle's altitude is increasing at 3 centimeters per minute. Its area is increasing also, as you'd expect. And the question is, how fast is the base changing? And the base could be growing also, or it could be staying the same. It could even be shrinking. It's possible that the base is shrinking a little bit, but the altitude's growing so fast that we're gaining area anyway. So for the moment, we don't really know anything about how the base is behaving, but we must find out. They ask how fast is the base changing, which would be dB dt, when the altitude up here, I usually just say height and call it h, but they're using altitude, so sure, we'll go with that. We'll call it a. Down here is our base b. And they've told us some things about the area, so we need a formula that connects the measurements of a triangle to its area, and probably you know that one. The area of a triangle is 1/2 base times height, or in this case, 1/2 altitude times base. Now, all of these things are changing, or we have to assume that the base is changing because we're trying to find dB dt, which means there's not really any way to get rid of any of these variables. This thing has 3 variables and we have to deal with it that way. So when we differentiate it, the derivative of a is no big deal, it's dA. On the right side, the derivative goes right through the 1/2. And then we hit AB, and when we do, the product rule fires. And it says that we have to do first d second plus second d first here. Now, that's not too bad with just variables to the first power. We get first d second plus second d first. And then we divide everything by dt, as we so often do. And there's our rate equation. I'm debating, I think I'll distribute that 1/2 through just because the brackets displease me a little bit. So we get dA dt equals 1/2 a dB dt plus 1/2 b dA dt. Okay, so that's all the stuff we need to know. How much of this can we actually fill in? They say the area is increasing at 9 per minute. That's our area dt. In retrospect, I kind of wish I'd used h for the height because now I have capital A and lowercase a, and that's not a great way to run a formula, so I apologize for that, but we'll make it work. The area rate is +9. We're gaining area. We have 1/2. The altitude, they tell us, is 20 at the instant that we're interested in. dB dt is the thing we're trying to find. I don't know what it is. Stay tuned. Then we have 1/2. We have the base. We don't have the base, do we? Okay, we'll circle around and get that in a moment. dA dt is how fast the altitude is changing, and they tell us that's +3. Okay, so there's everything filled in except for the base, which they didn't give us, so incredibly enough, side calculation time. At the instant we're interested in, the altitude is 20 and the area is 300, and so if we know that area is 1/2 altitude times base, if the area is 300 and that equals 1/2 of 20 times something, that means 300 equals 10b. Our base must be 30. So over here, in our spot reserved for the base, 30 goes in there. Okay, so now we got all this filled in. We should be able to dig dB dt out of here if we're brave and tenacious enough. We get 9 equals half of 20 is 10 dB dt, plus half of 30 is 15. 15 times 3 is 45. Subtract 45 from each side, and we get -36 equals 10 dB dt. And then you divide by 10, and you get dB dt is -3.6. Now this is base units over time units, so it ought to be centimeters per minute. So it turns out the altitude's growing, and that's giving us area. The base is actually shrinking at the same time, and so these two sides are in a race, trying to, they're fighting over whether the triangle is going to gain or lose area. And for the moment, the altitude is winning and the triangle is gaining area, but that probably won't persist forever. If the base keeps shrinking like this, eventually the triangle will shrink away to nothing and its area will go to zero. But for the time being, at the instant that they ask us about it, the base is losing 3.6 centimeters every minute.